Something on Mars has been moving for over a decade. The man who discovered it was barely old enough to drink, and the answer has outrun him ever since. He wasn't looking for it. He was a student, doing the boring work, comparing old photos of the same slopes, one season against another. And in the pictures, dark streaks were appearing, growing, then vanishing, then coming back a year later in the same places. He was 21 then. He's in his mid-30s now, and he has spent his entire adult life on this one question. It still hasn't been answered, not because the data ran out, but because somewhere along the way, the people who could answer it decided to look away. To understand why, you have to start with what he saw. His name is Lujendra Ojha. In 2011, he was an undergraduate at the University of Arizona, working under a planetary geologist named Alfred McEwen. The tool in front of him was a camera called HiRISE, mounted on a spacecraft orbiting Mars since 2006. It's the sharpest eye humanity has ever held over another world. It can pick out something the size of a kitchen table from 300 kilometers up. It has photographed the rovers themselves, tiny dots at the end of long trails in the dust. Ojha's job was routine. Line up images of the same terrain, taken months apart, and look for changes. Most days, nothing changes on Mars. That's the whole point of Mars. It's supposed to be finished. And then he found the lines. Dark, narrow streaks, only a few meters wide, running downhill from the rims of certain craters. In one set of photos, there. In the next, months later, gone. A year after that, back again, in almost exactly the same spots. He flagged it to McEwen. They pulled more images from all over the planet, and the pattern held. The streaks appeared on warm, sun-facing slopes during the Martian summer. They grew, they lengthened, and they faded the moment the planet cooled. They gave them a name: recurring slope lineae. For the rest of us, the dark streaks that move. A 21-year-old had just found the most active thing on a planet everyone had written off as dead. Stop and think about what that means. The surface of Mars is, by every reasonable measure, dead. Average temperature around minus 60 degrees Celsius. An atmosphere so thin, less than 1% of Earth's, that liquid water should boil away almost the instant it appears. This is not a place where things flow. It's a frozen, irradiated desert that has stood still for billions of years. And yet, here were features behaving exactly like flowing water, starting at a fixed point, running downhill, governed by temperature, coming and going with the seasons. Show those images to a geologist. Tell them they came from Death Valley, and they'd say, that's a small spring. For 4 years, Ojha and his team chased it. Because behavior isn't enough, sand could slide down a slope and fake it. To prove water, you had to detect water. In 2015, they did. Another instrument on the orbiter read the chemical fingerprints in the light bouncing off those slopes. And it found something specific: hydrated salts, perchlorates, salts that dramatically lower the freezing point of water, enough to keep a brine liquid at the temperatures actually measured there in summer. And the salts showed up exactly where the streaks were, only when the streaks were active. The student who'd spotted the lines 4 years earlier was now the lead author of the paper. At 25, he sat on stage at a global NASA press conference. NASA didn't just publish. They broadcast it live. Every news channel. Trending on every platform on Earth. The message was historic. Liquid water still flows on Mars today. Not in the ancient past. Not miles underground. On the surface, now. And where there's liquid water, even salty toxic water, there is at least the possibility of life. On Earth, bacteria thrive in brines, saltier than the Dead Sea. Some live inside salt crystals in the driest desert on our planet. For the first time, we had a specific address on Mars where you could land and have a real chance of finding something alive. For Oja, this should have been the beginning. The clean win. The start of a career spent going back for the answer. Instead, the room went quiet. Almost the moment the cameras switched off, other scientists started pushing back. Not on the data. The salts were real. The streaks were real. The pattern was real. They pushed back on what it meant. If the streaks were truly wet, they'd need a source, something recharging them year after year. But Mars has no rain, no rivers, and the streaks only ran on slopes steep enough that dry sand would slide too. They never crossed flatter ground. Real water would pool, seep, leave a residue. These didn't. In 2017, a new team offered a quieter explanation. The streaks weren't liquid at all. They were dry avalanches of fine, dark sand, creeping down the slope like flour off a tilted plate. The discovery Ojha had spent years building was, within 24 months, downgraded to probably dry. Buried in that 2017 paper is a single sentence that does an enormous amount of work. Roughly, if the streaks are mostly dry, then the water volumes may be small or zero, and that would ease the concerns about habitable environments. Translate it. If this is sand, not water, we no longer have to treat it as a place where life could exist. The barrier to sending a rover there disappears, and with it, the obligation to look harder. That wording didn't appear by accident. In the news cycle, the dry sand story was easier to tell, less exciting. It made fewer demands, and slowly, it replaced the 2015 announcement in the public mind, while the man who started it all kept doing the science, quietly, without the answer he'd been chasing since he was 21. Now here's the part that doesn't sit right. We have rovers on Mars right now, nuclear-powered, able to climb, to drill, to run chemistry on whatever they find. Not one has ever been sent to one of these streaks. Not one has been allowed to. The official reason is planetary protection. Rules meant to stop Earth microbes from contaminating a place where life might still exist. If there's any chance the streaks are wet, we can't risk infecting them. That's a legitimate rule. But look at what it produces. The one place on Mars where the question of life is most urgent is the exact place we've agreed not to touch. And notice something. People assume there must be a cover-up, that someone is hiding the answer. But that's not what's happening here. Nobody is hiding anything. The photographs are public, the papers are published. OHA will talk to any journalist who asks. The streaks are cataloged, studied, measured, and every Martian summer, high rise, photographs them doing it again. All of it, right out in the open. Nothing is being buried. That's what makes it strange. There is no locked vault, no shredded file, no secret. The most important question on another world is sitting in an open archive that anyone can download. And we have simply decided not to go and check. Ojha is 35 now. He spotted the streaks at 21. The question that has defined his entire adult life is no closer to an answer than the day he flagged it. Not because the data ran out, but because we stopped following it. The orbiter is still up there. The streaks are still moving. And every summer on some slope facing the sun, something we can't quite name slides downhill, dries, fades, and waits for us to come back next year and watch it happen again. So it isn't a secret we're keeping from the world. It's a question the world already has the answer to, sitting on a hard drive, one rover drive away. And no one has decided it's worth walking over to read.